Hello everyone, and welcome. Today, we're going to break down a simple but super important word in organic chemistry, planar. What does it mean when we say a molecule is planar? It's all about shape, and understanding this concept will help you visualize molecules in a whole new way. So, what does planar mean? In the simplest terms, planar means flat. Imagine a perfectly flat sheet of paper. If you can lay all the atoms of a molecule onto that sheet of paper without any of them sticking up or down, then that molecule is planar. Think of a dinner plate, it's planar. Now think of a soccer ball, it's three-dimensional and definitely not planar. This flatness isn't just a fun fact, it has huge consequences for a molecule's stability, how it reacts, and how it interacts with other molecules, like enzymes in your body. How can we spot a planar molecule or a planar part of a molecule? The biggest clue is in the atomic hybridization. You'll want to look for atoms that are sp2 or sp hybridized. Remember, sp2 hybridized atoms, like those found in double bonds, create a flat arrangement called trigonal planar geometry, with bond angles of about 120 degrees. All the atoms connected to that sp2 center lie in the same plane. Similarly, sp hybridized atoms, found in triple bonds, create a linear shape with 180-degree bond angles. A straight line is always flat, so it's always planar. On the other hand, sp3 hybridized atoms, like in methane, form a 3D tetrahedral shape, which is not planar at all. Let's look at some classic examples. Take ethene, C2H4. It has a carbon-carbon double bond, so both carbons are sp2 hybridized. All 6 atoms in the ethene molecule, the 2 carbons and 4 hydrogens, lie perfectly in the same plane. Another famous example is benzene, C6H6. Benzene is a ring of 6 carbons, and every single carbon is sp2 hybridized. This forces the entire ring to be perfectly flat. This planarity is a key requirement for benzene's incredible stability, a property we call aromaticity. Even smaller molecules like formaldehyde are planar because the central carbon is sp2 hybridized. It's also important to know that sometimes an entire molecule isn't planar, but a specific part of it is. For example, in proteins, the peptide bond that links amino acids together forms a planar group of atoms. This localized flatness is critical for determining the overall 3D structure and function of the protein. So, you can have planar regions within much larger, non-planar structures. To recap, planar means flat. Look for sp2 and sp hybridization as your main clues. This flatness is crucial for understanding molecular properties like stability and reactivity. I hope this explanation helped clear things up. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more easy-to-understand chemistry tutorials. If you have any questions or ideas for another video, drop them in the comments below. See you in the next one.